Begin by diving into the world of computer science. As a novice, you might be familiar with different algorithms and the concept of recursion. Today, we are going to explore implementing a classic algorithm, the Fibonacci sequence, in Python. Now, don't worry, we won't be going too much into abstract computations. Our focus will not only be on achieving the result but also on understanding how it is done in the world of Python. First, let's start at the very beginning. The Fibonacci sequence is quite simple yet powerful. It begins with 0 and 1, and every subsequent number is the sum of the previous two. Sounds easy, right? Let's start coding by first writing a simple recursive function to generate the first n numbers in the sequence. In Python, we define a function using the definite keyword. We'll also mark the end of the function with return. Let's define a recursive function named Fibonacci that takes an argument n. Now, remember in recursion, we've got to consider our base cases, like the first and second numbers in the Fibonacci sequence are always 0 and 1. So that would look like this. Python definite Fibonacci, if n is equal to 0, return 0 if n is equal to 1, return 1 else, return Fibonacci plus Fibonacci, great. Now, we have our simple Fibonacci function. Let's test it with something small. Say n is equal to 7. And voila! You get the first 7 numbers in the Fibonacci sequence. Moving on, we'll discuss an iterative approach. Now, this one is about improving efficiency over recursion when generating large sequences. The idea is to use a loop and keep track of only the last two numbers, using a variable for the current and the previous to generate the next Fibonacci number. Python definite Fibonacci underscore iterative, a, b is equal to 0, 1 for underscore in range, a, b is equal to b, a plus b return a. That was the nitty-gritty part, the coding bit. But as an IT fresher, understanding why an algorithm works is just as crucial, right? Well, let's dive into some theory. The time complexity of our recursive function is O, mainly because we are calculating the same subproblems multiple times. However, by using iterative logic, we've improved our time complexity to O. We can bring that time complexity down further using a technique called memoization in the recursive approach, similar to dynamic programming. Here, instead of recalculating the same things, we store the results of the expensive function calls in a lookup table and retrieve the values when needed, reducing time complexity to O. Python definite Fibonacci underscore memo, if n happy smiley 1, return n l if n not in memo, memo is equal to Fibonacci underscore memo plus Fibonacci underscore memo, return memo. Now, just as we've seen before, let's take n is equal to 10 and generate the sequence. But hey, why stop here? Let's try even something mind-bending, matrix exponentiation method. Yes, you read that correctly, we are going to use matrices to compute the Fibonacci sequence. Exciting, isn't it? Python definite fib, if n is equal to 0, return if n is equal to 1, return old is equal to fib new is equal to plus old for I in range 1, return new plus the first n plus 1 Fibonacci numbers in matrix multiplication of is 2358n, where is phi is equal to 2. There you have it. I hope you've found this deep dive into the Fibonacci implementation in Python both interesting and educational. Now, as you close this article, let's recap the various methods we've looked at and what you can do to learn more about this and similar algorithms. Don't forget to pay attention to their time and space complexities as they affect performance. Always look to optimize, test, and understand. I've always believed that coding is an art form that requires constant learning and practice. Experimenting with these algorithms in different languages and contexts can give you a broad perspective. And remember, the world of code is filled with endless possibilities. If you want to explore more about Python or coding fundamentals, there are innumerable resources out there. But here, I'll leave this one open. It's time for you to discover the wealth of knowledge out there for yourself. Lastly, don't forget, visit neeraj.qzz.io and subscribe to TechLab for more enlightening content. Keep growing as a coder.